Hello everyone, my name is Gunadi Gideon with the student ID DSC2409074, and today I'm going to discuss about the cost, revenue, and profit function along with the marginal function and also the average function. I will also discuss about the disk and washer method, and last but not least, I will also cover about the moments and center of mass. Okay, so we will start by learning about the cost function. The cost is the total cost of producing output, and it is represented by Cx. Now, the function consists of f, which is the fixed cost. Fixed cost is a cost that exists whether or not products are produced or not. And there's also the Vx. Vx is the variable cost, and it varies depending on the output. Okay, now we need to know about the marginal cost, which is the additional cost of producing an additional unit of output. And it is actually the first derivative of the cost function. So it's just Cx and x, like this. Now for the average cost function, I'll represent it by ACx. Is the cost function divided by the number of product produced, or the quantity of production, which is x. So the x in the cost function, in the Vx, is actually the number of products produced. Okay, so this is the cost function. Okay, this is the cost function. We'll continue with the revenue function. Revenue is represented by Rx, and the formula for revenue is Px. Okay, so we need to know the definition of revenue. Revenue is the total payment received from selling a good or performing service. So the x in here is also the same as x in here, which is the number of output or number of products. So, well, the P is the price. So this is the price. Okay, for the marginal revenue is also the same, which is Rx and x, which is the first derivative of Rx. And for the average revenue function is ARX, which is equals to Rx over x. This is the revenue function. Okay, continue. Let's go to the profit. So the profit function is actually the difference between the Rx and the Cx, which is the difference between the revenue function and the cost function. Sorry, I'll close the window. Okay, sorry about that. So Px, which is the profit function, is represented by Px is equals to Rx minus Cx. For the marginal profit function is also the same, which is the first derivative of Px. And for the average profit function is Apx, which is equals to Px over x. And this can be equals to Rx minus Cx over x. Because in some question, the profit function is not given, but we need to find it on our own. Okay, so this is the profit function. Okay, now let's go to the example of question. We'll get a question example to get a better understanding. So let's say a company, we have a company which have a fixed cost. A store or a company have a fixed cost. So they have a fixed cost, which is, let's say, 150 ringgit. 150 ringgit. This is the fixed cost. And the variable cost is, so the variable cost per unit is 175 ringgit. And they sell its product at 500 ringgit per unit. So they sell product 500 ringgit per unit. Now, if we are told to find the cost function, so the Cx is equal to the fixed cost, which is 150, plus the variable cost, which is 175. But because we don't know how many output or how many products are sold, we write it 175x. This is the cost function. Okay, now if we are told for the revenue function, the Rx, so it is the P multiplied by X. And the P in here is what, 500 ringgit. So 500x. That is the revenue function. Last but not least, we have the profit function. And it is just a difference between Rx and my Cx. So Rx minus Cx, which is equal to 500x minus 150 minus 175x. Thus, the result will be 325x minus 150. This is the profit function. Okay, we are defined all three results. Very simple. Now moving on to the next example to find the marginal function. So let's move on. Okay, so let's say we have a company and they produce a product. And we are given the cost function, which is Cx is equals to 500 plus 10x plus 0.25 x squared. And also the Rx is also given, which is the revenue function, which is 30x minus 0.1 x squared. Now let's find the profit function first before going any further. So the profit function is 30x minus 0.1 x squared minus the cost function, 500 plus 10x plus 0.25 x squared. So we get the result of 20x minus 0.35 x squared minus 500. This is our cost function, our profit function. So this is just to make it simpler for us in the next question, which we are told to find the marginal cost, the marginal revenue, and the marginal profit. So the marginal cost is just the derivative of Cx, which is 10 plus 0.5x. This is the marginal cost. Next, the revenue cost, Rx, which is equal to 30 minus 0.2x. This is the marginal revenue. Marginal revenue. And for the Px, it will be equal to 20 minus 0.7x. This is the marginal profit. Okay, let's move on to the next question, which is about the average cost, average function, average cost function, average revenue, and average profit. Okay, so let's use a different example. In here we are given the cost function, which is Cx is equal to 100 plus 20x plus 0.5 x squared. Revenue revenue is equals to 50x minus 0.2 x squared. In this case, we are given the profit function because we already know how to do it, so I'll just give the profit function in here, which is minus 100 plus 30x. Wait, this seems similar. Minus 100 plus 30x minus 0.7 x squared. Now to find the the average, we need to divide all of this by x. So over x, over x, over x. So for the average cost function, it is 100 over x plus 20 plus 0.5x. For the revenue, ARX is is equals to 50 minus 0.2x. And for the profit, average profit function, this will be minus 100 over x plus 30 minus 0.7x. This 3 is the average cost, average revenue, and average profit. Okay, moving on. We will learn about the disk and washer method. So, about the disk method. The disk method is a way of finding a volume with solids of revolution. We slice method using solids of revolution. But sometimes when using the disk method, there are revolutions that have cavities in the middle. Thus, they are not valid all the way to the axis of revolution. Thus, we need to use the washer method. And washer is a disk like this with a hole in the middle. Okay. So, suppose we have a function fx and gx, and fx is bigger than gx or equal to gx, and they must be continuous and non-negative function, and they pass over a comma b. Okay, so now let r is the region bounded by the graph of fx. So this is the region bounded by the graph of fx, while below the graph of gx, so they are r is the region bounded by these two graphs. So they have the line x equals to a and x equals to b. Thus the solid of revolution is in the formula. So v equals to pi square bracket the outer radius minus the inner radius. This is p8. So the outer radius minus inner radius. This is the formula for finding using the washer method. Okay, let's move on to the example of question. Oops, sorry, I should not delete that. Let it be. I'm gonna let it be. Let's make a new page to do the example of question. So let's say we have a volume of solid which is generated by revolving the region bounded by the parabola, which is y equals to x squared. We have y equals to x squared and y squared equals to 8x. About the x-axis, so it's about the x-axis. It's quite crucial. About the x-axis. Okay, so we already know. Let's just find the intersection point, which is, let's substitute this x squared into here. So it will be x power 4 equals to 8x. And should I do this here? Yeah. So x power 4 minus 8x is equals to 0. X power 3 minus 8 equal to 0x. So the x could have value of 0 or x have a value of 2. Okay, so now this will be our B and A. So we will make the graph like this. This is the volume equals to 2, 0. Now for the outer radius, it will be square root of 8x, and it exists because y squared equals to 8x and y is equals to square root of x. So therefore the outer radius is square root of 8x. Square root of 8x. Let's put the pi in front here. Minus, it's power 2 because it's a radius. Now it's minus by the inner radius, which is already given in here, y equals to x squared. So it's x squared. X squared squared. So be x squared squared like this. X squared squared. Okay, dx. Now we can find the results in here. I'll use a different color. So v is equals to pi 2, 0, 8x minus x power 4 dx. We differentiate this. and we got 4x squared minus 1 over 5 x power 5 to 0 pi here. Now we just insert the 2 inside there, so pi 4 multiplied 2 multiplied 16 minus 32 over 5, and so the result is 48 pi over 5. Okay, that's how to use the washer method. Now, last but not least, we'll discuss about the moments and center of mass. So we have center of mass, which is the point on with which a thin plate of any given shape balances, and moment is the product of the mass of a particle and its directed distance from a point. Let's just go directly to the formula because it will take a long time to explain. So let's say we have this m, this is for the total moment. M is the total moment, is equals to m1 x1 plus m2 x2 and so on until mn xn. Okay, so we can just simplify it by writing this ni equals to 1 mi xi, and for the center of mass I will represent it by this notation. It's the total mass over m. So the total mass, which is this, I root 1 mi xi over sigma n I1 mi. Okay, oops. Now for 2 points, so there is the point x and point y, center of mass for the x and for the y. So for the x we will use the my like this over m, and for the y it will be mx over m, and for mx is, okay, I'll write it here. So sigma ni1 mi y1 sorry, ni1 mi. Same goes for the y, which is sigma ni1 mi xi over sigma ni1 mi. So this is the formula for a system of n masses located at the points x1 and y1, x2, y2, and so on. To get a clear understanding, I think it's better to go to the example. So let's have an example here. We have a total mass, we have a mass load, for example, and it is, oops, sorry, okay, so we have a load with masses, three objects with masses 2 kilogram, 5 and 7 kilograms. This is also kilogram. Okay, they are located at the point 0.2, 3.1 and 4.3. Now we are told to find the moments about the x-axis and the y-axis. First we need to find what is m1, m2 and m3. So m1, m2, m3 is respectively the mass itself. So 257, and they are located in here, here, here. So this is the points of them: 0.2, 3.1, 4.3. This is the point for them. Okay, so this represents x1 and this represents y1, x1, y1, and this one represents x2, y2, x3, y3. Okay, now we need to find the moments. The moments, like we have said before, is mx. So mx is equals to sigma mi multiplied by yi. while for the y is sigma mi multiplied by xi. Same, okay? So what is mx? Before going further, let's just put what is m1 in here. So m1 is sigma m1, which is 2 multiplied by y1. y1 is 2, so it will be 4. For m2, oh, this should be in capital, sorry, not m1, but it's mx1, like this, mx1, mx2. mx2 will be 5 multiplied by 1, so it will be 5. And last, mx3, it will be 7 multiplied by 3, which is 21. Okay, now it's time to find the my. my1 is equals to 2 multiplied by 0, which is 0. And then there will be my2, which is 5 multiplied by 3, which is 15. my3, which is 7 multiplied by 4, which is 28. So we already know the most important. This. Okay, so if we are told what is the total moments, we just need to add mx1, mx2, and mx3 together. So it will result in, what is this, 30, while this one result in 43. So this is the total moments for mx and my. Total moments mx and my. Okay, still using the same example, we will do to find the center of mass. And to find the center of mass, it's divided into 2, so there will be the x1 and the x and the y. So let's say here xc, it is the total mass of y, which is 43, and it is divided by m, and the m in here is 2 plus 5 plus 7, which is the mass. So it will be 14. So the m is equals to 14. This is the center of mass for x. For y, it is 30, which is the total moment of the y and the x, over m, which is 14. So 30 over 14. This is the result. This is for the total mass, total center of mass for x, center of mass for y. Okay, that is it for this video. I hope you guys learned something new from this or get a better understanding with my explanation. And I hope to see you guys in the next video. See you guys and have a good day. God bless you.